I was going to wait until I had everything planned, everything laid out. But if I wait until I get all my ducks in a row, I might not ever make this video. What's the issue? The issue is the finely tuned universe and the problem of ice worlds. So there's a theory that there's a bunch of multiverses, and that the reason that we have the physical laws that we have in our universe is because we just happen to exist in a universe that we can observe. So, for instance, the constant for the fine structure constant 1/137, the all the coupling constants of the strong force, the mass of electron, all that kind of stuff is supposedly fine-tuned, and it's fine-tuned so that stars can form. We can have 15 billion years, and that we can live on this water planet, and that's why all the constants are like they are. But there's a huge problem with this anthropic sort of reasoning. This habitable zone doesn't make any lick of sense. So let's consider the habitable zone here in our solar system. We have the Earth. Okay. We have ice planets like Europa and possibly other ice planets around Jupiter and Saturn. And these ice worlds have a thick crust of about, 10 miles, 20 miles. But inside, they have vast, probably salty oceans that correspond with what we think life should be. Now, the problem with this is that we only have one planet with life that we know so far, intelligent life. But if you think of the anthropic principle, what's the difference between a fish, a dolphin, a whale, noticing the universe and thinking about it, and we could be in one of those ecosystems, a fish or a whale or something like that. And if you look at just the math, ice planets with a habitable ecosystem vastly outnumber the open ocean system that we have here on Earth. That's very troubling for the anthropic reasoning people. They want to say that because the constants are just so, that means that this is why the Earth is like it is, because we can observe. But fish don't have to see the universe. They can just be thinking beings, and you could be probabilistically more likely to be in one of those. But it gets much, much worse if you think about star formation. Because, okay, we know we need all the elements. We need the iron. Well, for life as we know, we need the iron, we need the silicon, the hydrogen, all the elements. That's fine. And we know you can make them inside stars. But you don't have to make them in stars. You see, you can make them in a collision of two neutron stars. You can make all the elements up to uranium. You can make them in a collision of neutron stars where they hit each other, combine a bunch of elements, and spit it all out. You can make them in the accretion disk around black holes, where you have hydrogen going to the accretion disk. It gets really, really hot. It gets sun in core of the sun hot. And those can fuse in the accretion disk of a black hole and spit them out. And if you think about it, you don't actually need the constants of the sun to exist. It doesn't have to be perfectly tuned. So, for instance, if the fine structure constant were a little bit different, you would not have fusion in suns, but you could still have all the elements that we know, but they would come only from black holes. And if you think about it, what's wrong with a bunch of ice planets orbiting black holes by the billions? And they probably already do. They're out there. We just can't detect them because we have no way of seeing such a cold body. There are probably millions more of these habitable zone ice planets. How do they keep warm? Well, the same way the Earth keeps warm. The Earth keeps warm not from the center of the Earth, keeps warm not from radiation from the sun, but from fission inside the center of the Earth. So these ice planets, despite not having any sunlight, could be in the habitable zone. So there's a huge problem here. By any kind of anthropic reasoning, we should not be on a water planet. We should be inside an ice planet, and we should be fish. That's the problem. That's the crux of the issue. That's why all this anthropic reasoning makes absolutely no sense. Now, here's what I was going to do. I was going to calculate all that stuff, and then I started thinking about entropy, and I thought, well, I should calculate the entropy and see if that is the reason. But I'm going to go on without any math, without any calculations, and try to explore a possible anthropic answer for why the universe is like it is, and also why there shouldn't be any habitable planets around red dwarfs. And that is, there are 2, 3, or 4 habitable zone systems we have to think about. One of them is, of course, the temperature, which is very simple. There's the temperature of the Earth. But there's also the idea about what? Am I boring you? I'm boring you. I'm boring you. Is that what's going on now? I'm bored. You're bored. Okay. The cat's bored. Play with the cat. I'll be right back. So there's this habitable zone issue about, not only do you have to be in the right temperature zone, you also have to be in the right part of the galaxy where you don't have as many supernova events. But the thing is, there's one issue which I think will solve our ice world conundrum and also explain anthropically why we're on a water world. And that is the fact that intelligence is an entropic engine. All that intelligence does is it takes in entropy, turns it into intelligence on one side and waste heat on the other. If you look at a red dwarf, the frequencies they get are half as much lower than the frequencies that our sun has. Our sun is centered around the color green, though it doesn't look green because we're evolved to see the sun as white, but if we had different eyes, we would see it as green, which the sun is. It's a fairly high frequency considering all the suns in the universe. Most of them are smaller and dimmer, and if you integrate over the lifetime of the sun how much entropy you get from the sunlight at that frequency compared to the entropy you get from a red dwarf, it's much less. Now, I haven't calculated that, and that's what I would have to do to make this more of a realistic scientific video, but I haven't done that. But I think there's something to that. What's more, the ice worlds, the Europas of the universe, these planets orbiting black holes that make fun of universes which have suns, the amount of entropy they get from the fission decay in the center of their tiny ice worlds radiating out is vastly, orders of magnitude smaller than the entropy we get from the sun. So I think the reason that we live on a water planet around the class of star that we're around is because we need all that entropy the sun is producing over 5 billion years in order to create the life that we know. These suns, like ours, are all going to go out because the universe is finite. It runs out of hydrogen. And eventually, when we just have red dwarfs, perhaps there won't be enough entropy for intelligent life. Perhaps we're right in the very window, right on the borderline of where intelligence is possible. Perhaps intelligence is very, very precariously placed. And that would explain anthropically why we have the constants that we have. We need the constants because we need an incredibly bright sun, which it is compared to red dwarfs, for a vast amount of time, 4 or 5 billion years. And it's incredibly suspicious in 1 more billion years to boil off. So, relatively, we achieved intelligence just in time. It's all very suspicious. But I think the habitable zone hypothesis has something wrong with it. And I think the solution is to look at entropy.